Hello and welcome to MathsBytes, where we discuss maths related to computer science. This is the 12th video in the binary numbers series, and in this video we will be discussing binary addition. Firstly, we will quickly revise how addition is done with decimal numbers, so we are all clear on the process and can modify it for the binary numbers. We will also spend some time on understanding how the role of the carry changes with the binary addition. Again, I will show you many examples, and you will also have a chance to practice the binary addition. So, let us quickly review how we add two decimal numbers together. Can you add together 472 and 9392? We will revise the traditional addition, and we will follow the same process as in the previous video. So, first we line up the two numbers, making sure the same place values are under one another. We will write the longer number on top, then we will write out the addition sign and underline the bottom number. Now that we set up the addition the right way, we can start carrying out the calculation. We will do the calculation digit by digit, starting with the rightmost digit. 2 add 2 makes 4, no carry, so record 4 and move one column to the left. 5 add 7 makes 12. We now have a carry of 1, which we record above the 3 and write down 2 under the line below 7. Again, we move one column to the left and add together 1, the carry, 3 and 4. They make 8. This time there is no carry, so we move on to the next column on the left. We have no carry in this column, and there is only one digit, the digit 9. So we just write this down. Therefore, the answer to adding 9,352 and 472 together is 9,824. Now that we are reminded about how we add decimal numbers together, let us think about what might happen when we want to add together binary numbers. So first of all, what are binary numbers? Well, at the most basic level, binary numbers are a bunch of zeros and ones. For example, 1, 0, 1, 0, 1, 1, 0, 0, 1 is a binary number. Throughout this video, I will group the binary numbers into groups of 4, starting from the rightmost digit and leaving a space in between each group. I find it easier to read the numbers this way, and I can make more sense of their magnitude this way too. The role of the space in these groupings is similar to the role of the comma in decimal numbers, where we group the numbers into groups of 3 for ease of reading. It is only a personal preference, however, not a common notation, so feel free to ignore this grouping if you find it confusing. So let us think about how we could add together two binary numbers. Since decimal addition was quite efficient when we carried it out digit by digit starting from the right, let us try doing it for the binary addition too. As in the binary number system, we only have two digits 0 and 1, there are fewer options of single digit addition. We can add together 0 and 0, 1 and 0, 0 and 1, or 1 and 1. Let us consider each option in turn. 0 and 0 add together to 0, no surprise there. 1 add 0 and 0 add 1 both makes 1, again, no surprises here either. Now, when adding 1 and 1, the solution should be 2. However, we do not have digit 2 in the binary number system. What is more, when you express the decimal 2 as a binary number, it is 1, 0. What happened here? Well, we ended up with a double-digit binary number when we added together the single binary digits of 1 and 1. This is the equivalent of reaching the sum of 10 or higher in decimal. So this is the case when the carry will turn up in binary. At the single digit level, we would write down 0 and carry 1 to the next column to the left. Well, can the carry turn up in any other cases? Yes, let us consider the case when we have to add together the binary digits 1 and 1 with the addition of already having a carry of 1 from the previous column. In that case, we actually have 3 binary digit 1s to add together, which sums to 3. 3 in binary is also a double digit number, 1, 1. So in this case, we would write down 1 and carry 1 to the next column to the left. You can probably agree with me that the carry will pop up quite often when adding binary numbers together. Now, are these the only possibilities for carry when adding two binary numbers together? Well, not quite. What if we already had a carry from the previous column? To investigate all these options, let us use a handy table again. So, how to use this table? Let us look at the first column. In the first cell, we indicate that this table is used for addition. In the two other cells in the column, we have the two binary digits 0 and 1. In the first row, we have all the options that can happen when we add a second digit and whether we have a carry or not. In the remaining cells, we will record the results of the sum in the digits and carries, if any. In the second column, we add 0 with no carry to 0 and also to 1. As adding 0 means we add nothing, the result of these two digits additions will be the same as the original digits 0 and 1, and there will be no carry. In the next column, we are still adding 0 to our original digits of 0 and 1, but now we also have a carry. So in the second cell, we add together 0, 0 and a carry of 1. The total here is 1 with no carry. However, in the next cell down, we are adding together 1, 0 and a carry of 1. These together make 2, which in binary is 1, 0, as I explained earlier. So here, the result of the sum will be 0, carry 1. Moving on to the next column. In this column, we are adding 1 with no carry to 0 and 1. In the second cell, we will get 1 with no carry, as we add 0 and 1 with no carry. However, in the third cell, we will get 0 carry 1, as we add together two 1 digits, which makes the binary 1, 0. And now, let us finish off the table by looking at the last column. In the second cell, we add together 0, 1 and the carry of 1. This sum results in the binary number 1, 0, so we record 0, carry 1 in this cell. And finally, in the last empty cell, we add together 1, 1 and the carry of 1. This will result in the binary number 1, 1, which is the decimal 3, as we discussed a few minutes ago. So we record 1, carry 1 in this cell. I hope you appreciate this neat table summarizing all the possible combination of adding two binary digits in a binary addition. I suggest we keep this table handy for the binary additions until we all feel confident doing the addition without it. I think, so far, we had a good go at thinking about the concepts in general, but we need to do examples to demonstrate what happens in practice. Let us do just that. Let us try adding together 1, 1, 0, 1, 1, 0, 1 and 1, 0, 0, 1, 1, 1, 0, 1, 0. First, we need to line them up correctly by placing the longer number at the top and lining them up so the rightmost digits, the unit digits, are under one another. Then we place the addition sign and underline the bottom number. So far, we did exactly the same steps as we did for decimal addition. Now, we are ready to start the digit by digit addition. The two rightmost digits are 0 and 1, and there is no carry. From our table, we can see that they add up to 1 with no carry. It doesn't matter whether you look at 1 at 0 with no carry or 0 at 1 with no carry. The results are the same. It is due to the fact that the order of addition can be changed without the final result changing. If you want to know how and why, and not just take my word for it, do a research on commutativity and associativity of addition. Have fun! Next, move one place value to the left. This step is again the same as with the decimal addition. The two digits here are 1 and 0 with no carry. They also add to 1 with no carry. So we move to the next place value. Here again, we need to add 0 and 1 with no carry together and record 1 with no carry. In the next place value column, we have 1 and 1 with no carry. From our table, we can see this sums to 0, carry 1. So we have to record 0 under the line for the result and a carry of 1 into the next place value column on the left. Now in the next place value column, we have 1 at 0, carry 1. Let us look at the table and see what should be done. From the table, we can either use the sum of 1, 0, carry 1 or 0, 1, carry 1. The result is the same, 0, carry 1. In the next place value, we have a carry 1 and 2 one digits in the original numbers. So from the table, we will use the cell that corresponds to the sum of 1 add 1, carry 1, which is 1, carry 1. Therefore, we will write a carry of 1 to the next column and add a 1 to the solution row. Moving to the left again, we have a 1 carry and the digits 0 and 1 from the original numbers. Looking at the table, these again are 0, carry 1. So we write the carry into the next column and the 0 to the result row. In the next place value on the left, we have a carry and only a 0 digit from one of the original numbers, as the other number doesn't have any digit at this place value. So let us consult the table again. However, there is no cell that is the result of 0 and add the carry 1. What are we to do? Well, this is a situation where knowing our numbers pays out well. We are going to call on the concept of leading zeros here. Every number in whatever number system, including the decimal and binary, can have as many zeros at the front as we need without these zeros making a difference to the value of the number. Remember, 0 in mathematics means nothing, so we are adding nothing to the value of the number. We call these zeros leading zeros because they are at the front, in a way, leading our number. In this case, we can add 2 leading zeros to our bottom number and then we can use our table as before. We add 0 and 0 carry 1, which will result in a 1 and no carry. In the leftmost place value, we have the digit 1 from our top number and the leading 0 from our bottom number and no carry. So the result will be 1. This is the same effect as if we were just to copy down the original digit 1. This concludes that the solution to adding together 1, 1, 0, 1, 1, 0, 1 and 1, 0, 0, 1, 1, 1, 0, 1, 0 is 1, 1, 0, 1, 0, 0, 1, 1, 1. I strongly encourage you not to think in terms of decimal digits when adding binary numbers together. Sure, it will be a little harder at the beginning to think in purely binary terms, but trust me, this initial extra effort on your side will pay out immensely once you master thinking in binary for these calculations. Let us do one more example slowly so you can get to review the rules in action again. The two binary numbers we will add together this time are 1, 0, 0, 0, 1, 1, 0, 1 and 1, 1, 0, 1, 0, 1, 1. Let's prepare them for the addition by lining them up correctly and underlining them like this. And start adding them together digit by digit from right to left. The rightmost digits are 1 add 1, no carry. Using the table, they will sum to 0 and carry 1. Move one place value to the left. Here we have 0 add 1, carry 1. These digits will make 0, carry 1. In the next place value on the left, we have 1 add 0, carry 1. So using our table, we record 0, carry 1. As we move to the next place value, we find 1 add 1, carry 1. These sum up to 1, carry 1. In the next place value, we have 0 add 0, carry 1. These add up to 1, no carry. So we just record this in the result row and move to the left. In the next place value column, we have 0 and 1, no carry. This simply add together to 1, no carry. We record 1 in the result row and move one place value to the left. The numbers in this place value are the same as the previous ones. We have to add together 0, add 1, no carry. So we write 1 into the result row and there is no carry here either. Now we reach the leftmost place value. There is only a digit 1 here, so we can add the leading 0 to the bottom number and there is no carry. The result will be 1, no carry, and we are done. Remember, if you want to use the table, you should always write out the leading zeros so you can identify the correct additions. The result of adding together 1, 0, 0, 0, 1, 1, 0, 1 and 1, 1, 0, 1, 0, 1, 1 is 1, 1, 1, 1, 1, 0, 0, 0. I will show you one more example, but this time I will do the calculation in a somewhat more natural flow without referring to the table all the time like in the two previous examples. Feel free to try to do this sum alongside me, or if you feel you still need more time to absorb the rules, pause the video now and again, and at each step explain to yourself the solutions in more details. Using self-explanation training can greatly enhance your understanding of new topics. I will link some more information on what self-explanation training is and how to use it efficiently in the comments section. The two numbers we will add together are 1 1 0 1 1 0 1 1 0 1 and 1 0 1 1 0 1 1 1. Again, we line them up in the correct position. Now we are ready to add these two binary numbers together. In the rightmost column, the unit column, we add together 1 and 1 and they make 0, carry 1. In the next column on the left, we have a carry of 1, 0 and 1. They make 0, carry 1 again. Moving one place value to the left, we have 1, 1 and 1. These all together make 1, carry 1. Next we have 1, 1 and 0, which add up to 0, carry 1. In the next column on the left, we have 1, 0 and 1. These make 0, carry 1. In the next column, we have 1, 1 and 1. These make 1, carry 1. Moving on, we have 1, 1 and 0. These again will add up to 0, carry 1. Next column is 1, 0 and 1, which will make 0, carry 1. In the next column, we only have 1 and 1. These will add up to 0, carry 1. The next column is the same. It has the digits 1 and 1. So we can again write down 0, carry 1. Now the original numbers don't have any more digits, but we still have a carry 1. So we just copy this into the result row, as there is no other digits to add to it, and now we have the final result. The sum of 1 1 0 1 1 0 1 1 0 1 and 1 0 1 1 0 1 1 1 is 1 0 0 0 0 1 0 0 1 0 0. I hope you had been able to follow through with this last addition, where we turned up the heat a little and went quite a bit faster. However, if this was a tad too fast for you, do not lose faith. Speed comes with practice and practice only. I can do this calculation fast and with ease because I have done hundreds of them, with the added advantage that I had to explain them to multiple student groups over many years. If you had my experience, you would be able to do them just as well. So, get some paper and pen at the ready and pause the video shortly to start on your journey to mastering binary addition by trying to add together the following numbers. Remember to use the table if you are still a little unsure of the rules. And here are the answers. I hope you got all of them right, but if not, don't get upset. Remember, mistakes are learning opportunities. They are trying to teach you something you haven't quite grasped yet, or you glanced over in previous practice questions. Also, don't expect yourself to be a master of binary addition after trying 5 questions. You need to do some more practice questions. Ideally, try to do a few questions each day until you feel confident you can do any questions. And once you reach that level, keep practicing at different intervals. True masters keep practicing these skills again and again. Before we finish off the video, I would like us to look at the digit addition table again. Here it is. Now, let us look at how many different answers are there and if we can group them in some way. If we look at the result cells in the table, there really are only 4 different types of answers. 0 no carry, 0 carry 1, 1 no carry and 1 carry 1. When do they occur? Well, 0 no carry only occurs when we add 2 0 digits and there is no carry. However, 0 carry 1 and 1 no carry happens quite often. 0 carry 1 will be the result every time when we add together the digits 1, 1 and 0, regardless of order or which digit is the carry. Similarly, 1 no carry will be the result when we have 0, 0 and 1 to add together in all the different combinations. Lastly, we will get 1 carry 1 only when we need to add together 1 and there is a carry. So if you know these patterns, you no longer need the table. Now let us summarize what we covered in this video. Once we reviewed how decimal addition works and remembered that we add numbers together digit by digit, we looked at how individual digits of binary numbers can be added together. We followed the same procedure but established that when adding binary numbers, the carry will happen much more often. For example, 1 add 1 is 1 0 in binary, so the solution is already a double-digit number and we need a carry. Once we looked at all the different ways the binary digits of 1 and 0 can be added together, not forgetting the carries, we presented our findings in a neat table. We worked through 3 examples and you had a chance to practice 5 binary additions. In the final part of the video, we established that there are only 4 different results to these digit additions and they occur as follows. 0 no carry will be the result of adding together 0 and 0 with no carry. 0 carry 1 will be the result of adding together 1, 1 and 0 in all the possible combinations. 1 no carry will be the result when adding together 0, 0 and 1 in all the different combinations, and 1 carry 1 will be the result when we add together 1, 1 and have a carry of 1. I hope you have grasped the basic ideas behind binary addition and you feel confident attempting these additions on your own. However, do use the table to add the numbers together if you feel a little unsure still. Also, it is perfectly normal to feel you need more practice, so do more practice. In the next video, we will establish a series of step-by-step instructions for carrying out binary additions. Until then, keep learning one byte at a time.